Today I'm going to discuss about the hydrogen oxygen fuel cell. My name is Ramesh. I'm one of the assistant professors in the Mrec. So generally the galvanic cell, if we consider, it is an electrochemical cell where the chemical energy can be converted to the electrical energy. So the main purpose of these batteries is to convert the chemical energy to the electrical energy. So in case of the batteries, right, the batteries they are going to act as a galvanic cell or like an electrochemical cell. At the same time, the chemical energy can be converted to electrical energy, and also electrical energy can be converted to the chemical energy also. So as we know that the batteries are of two types. One is a primary battery, one is a secondary battery. In case of the primary batteries, the complete chemical energy is transformed to the electrical energy, and there is no chance of again restoring the chemicals during that process. Means the complete reactants will be transformed to products. Again, the products cannot undergo the decomposition or not dissociation process if you are supplying the energy also. Whereas the secondary energy sources, if we consider, right, lead acid batteries, nickel cadmium battery, right, and not only that, even this in case of these batteries, if you consider, both they are going to operate like an electrolytic cell at the same time electrochemical cell. Means the chemical energy is transformed to electrical energy, and again the electrical energy is transformed to the chemical energy. So that is what in case of the batteries, both the process are taking place, and in build we are going to consider the chemicals, we are going to consider the electrodes inside in it, and it is operated and it is widely used for different purposes also. And here today's concept is hydrogen oxygen fuel cell. So what is the difference between the normal batteries and then hydrogen oxygen fuel cell? Here the hydrogen oxygen fuel cell, even these batteries are also they are going to operate like an electrochemical cell system. But the main difference between the normal batteries and then the hydrogen oxygen fuel cell or the fuel cell is nothing but here the chemical energy is provided by the fuel, not by the chemicals. Fuel is nothing but a combustible material or a carbonaceous material which can undergo the combustion and going to give the large amount of the heat and the light energy. Right. So here the chemicals are not providing this chemical energy there. The fuel is like hydrogen, propanol or methanol, like these hydrocarbons or the hydrogen, they are acting as a fuel and they are producing the chemical energy. And this chemical energy is converted to the electrical energy there. Okay. And there the charging and the discharging process will be taking place in case of the batteries. But here only discharging process will be taking place. That is, the complete chemical energy is converted to the electrical energy. As long as we are supplying the reactants like hydrogen or the oxygen, these batteries are going to work or batteries are going to operate here. Means here when we stop supplying this hydrogen or any other hydrocarbon along with the oxygen, that is oxygen, we can stop this act. And nowadays in the coming generation also, these batteries, these fuel cells, they are going to play an important role in the coming generations also, right? So first we'll see the history, and then the hydrogen energy, the fuel cell, and the importance of the fuel cell technology and working of the fuel cell, the types of the fuel cells, and the importance of the hydrogen, that is a fuel, and then hydrogen production, finally the applications and the benefits of the fuel cells, right? We'll get into this concept now. If you consider the history, in 1838, right, a German scientist, that is a Christian Friedrich, okay, he discovered the fuel cell there, that we can produce the electrical energy by making use of a fuel. Also that concept was discovered by him, right? Later in 1839, it was demonstrated by the Welsh scientist, that is William Robert Grove. Okay, he demonstrated this particular fuel cell experiment here. And hydrogen energy, if we consider hydrogen, it is the first element in the periodic table whose atomic number is 1. Proton is going to present in the s orbital, that is 1s1, and it is going to have both the metallic and also the non-metallic properties, right? It can exist as a proton, it can exist as an hydrogen also, right? Because of that, it is placed separately in the periodic table above the alkali group elements. This particular hydrogen is placed separately, and we are going to study about the hydrogen and its compounds separately, right? And it is one of the simplest element and also most plentiful element in the universe. right? Also, it can combine with other different other metals, non-metals, and then even if you consider with the carbon also, it is going to form n number of millions of the compounds. That is, the carbon compounds are also formed by this, the hydrogen element itself, right? And it is going to produce a large energy also. High energy will be produced by this, okay? And also, it is not going to cause any pollution, right? Our pollution is almost zero emission, zero. The emission of zero pollution emission will be there because by this the hydrogen. And right now, even the NASA also, they are using this liquid hydrogen since from 1970 onwards. They are using, okay, as a fuel in the rockets. They are using this one, right? What is a fuel cell? It is an electrochemical cell which is used to convert the chemical energy to the electrical energy. In case of this fuel cell, the best example for the fuel cell is in the hydrogen oxygen fuel cell. Here we are going to use the fuel, that is a hydrogen. We are going to use an oxidant, that is oxygen. Oxygen is a supporter of combustion. Without oxygen, we cannot combine any, we cannot undergo any combustion process there. So we, in order to burn any substance or in order to undergo any sort of reactions, that is a combustion reaction, oxygen is must here. So that oxygen, when you are supplying from the one end, right, from another end, if you are supplying the hydrogen, right, without combustion reaction, right, because of the redox reactions here, they are going to produce the byproducts and the main products there. Now, if we consider the hydrogen oxygen fuel cell here, the hydrogen and then it will undergo the oxidation and then oxygen will undergo the reduction process, and due to this, the water, as it is forming as a one byproduct there, along with that, we are going to get the electrical energy. Again, from the water, we are not going to restore, we are not going to dissociate that water, decompose that water to get the products, that is the hydrogen gas and then oxygen gas. See, the hydrogen, it is a gas here, oxygen is a gas, and the water, it is a liquid substance here, right? And then generally we know that oxidation is nothing but the loss of electrons is called oxidation. Reduction is nothing but the gaining of electrons is called reduction. So here the hydrogen, which is present at the anode, okay, it is undergoing the oxidation process, and then oxygen, which is sent from the another outlet, right, where it is going to undergo the reduction process by gaining electrons, right? So there's like this, the redox reaction which is taking place between the hydrogen gas and then oxygen and producing the electrical energy along with the byproduct, that is a water also we are going to get in this process. So it is this fuel technology, it is very important right now, as it is a widely used the fuel cell here. Why? Because see, the batteries concept, why they introduced just to the, why can't we produce the electricity from the chemicals? Why only in the natural fuels like fossil fuels itself we have to consider? When then all the natural fuels like coal or the petroleum or the natural gas, when they get exhaust, then what is the source for us? Even though the alternate energy resources are there, right? And why can't we produce the electricity from chemicals, right? From this thought, this particular batteries, the concept came, and after the batteries, and we are depending on the fuels also. Okay, and this is not a fossil fuel. The hydrogen is not a fossil fuel. Okay, coal, petroleum, natural gas, they are going to act as a fossil fuels, right? So here the conversion of this fuel to the energy, it is going to take place through the electrochemical process. That too, the redox reactions are taking place, but not combustion. The combustion of the hydrogen gas is not taking place in this process. Really, the fuel cell means all will think that the fuel, it is going to undergo the combustion. The combustion chamber will be there so that it will be undergoing the reaction. Okay, it is going to produce the smoke, it is going to produce the heat energy like that, but it is not going to undergo the combustion reaction, right? It is not going to emit any of the toxic gases or the harmful gases into the environment also. It is a clean, quiet, and highly efficient process, that is the fuel cell, right? And then even 2 or 3 times more efficient when compared to that of the normal fuel burning also. That is the redox reaction which is taking place in this fuel technology also. And how does the fuel cell work? It's almost like an electrochemical cell. It operates like an electrochemical cell, the galvanic cell, but it does not run down or nor does it require the recharging, right? Why? Because then the products are not transformed to reactants in this case. As long as this fuel is supplied, the fuel cell will produce both the heat and then energy here, the electrical energy, that is. Generally, the fuel cell consists of the catalyst coated electrodes there, which are calling it as the porous electrodes. These generally the porous electrodes are coated with, they are impregnated generally with the platinum or the silver, right? The anode and then cathode, they are the porous electrodes here. On the left side, the anode will be there. On the right side, the cathode electrode is going to be there. Okay, and the actual process, that is the redox reaction, takes place when the hydrogen gas, when the hydrogen molecules, when they enter from the inlet to a separate inlet from the left side of the compartment, and whereas oxygen will be sent into this chamber, right? That is the hydrogen oxygen fuel cell apparatus from the right side. When the gaseous substances, when it enter into the fuel cell, then only the redox reaction will be taking place. Reduction and oxidation will take place here. And what are the catalysts that we are using there? It is coated separately. The hydrogens, both the anode and then cathode, its role is just to perform the oxidation and the redox reaction itself, right? And then the interaction will be between the hydrogen and then oxygen itself, right? And then we are going to use different types of electrolytes here. We can use potassium hydroxide. We can use the different other alkaline substances also as an electrolyte, and we can produce this electricity also. And then electrolyte like potassium hydroxide, if we consider, it allows the protons to pass through the cathode, but not the electrons here. How we are getting the protons means by undergoing the oxidation. Oxidation is nothing but the loss of electrons. Then the hydrogen molecule, when it undergoes this oxidation, it is going to form the 2 moles of the H plus there, nothing but the protons there, right? And these protons will be passing towards the cathode, and there at the cathode, the oxygen and the protons, they will undergo the reduction process and going to form the water, right? So the electrons are not transferred from anode to cathode here. The protons are transferring there, right? Instead, not only that, even the electrons, when they pass through this electric circuit, only the oxygen molecules can pass through the cathode there. Okay, so the protons, oxygen, and then by gaining electrons, it is going to produce the water here, right? And this is what a simple diagram which shows that how the hydrogen, from which end it is sent into this the fuel cell, that is hydrogen from as a fuel, it is acting there, anode and nothing but the graphite, the carbon electrodes itself, this one which is impregnated with platinum or the silver, right? Anode, and the right side the cathode. Oxygen is from the separately through cylinders. We are hydrogen and oxygen will be separately sent through the 2 inlet here. And from right side we are sending the oxygen gas, and from left side we are sending the hydrogen, and both will undergo the redox reaction. At first the hydrogen is converted to the proton, and the protons will be passing through this electrolyte towards the cathode, and the interaction will be taking place between the hydrogen gas and then oxygen, and then electrons are going to form the water. And the byproduct is nothing but the water, and the electrical energy is produced and it is stored there. And these are the different types of the fuel cells if you consider. The first one is the proton exchange membrane, PEM it is. Here the electrolyte used is a solid polymer membrane, right? Solid polymer membrane, and then anodic gas is nothing but the hydrogen, nothing but the fuel is nothing but hydrogen. Cathodic gas is almost, we are going to consider the atmospheric oxygen itself is going to act as an oxidant in almost all the different types of the fuels, because it is a supporter of the combustion process. It is essential for the redox reaction to form the product state, right? And the temperature is almost 75 degrees of temperature, and the efficiency will be almost 35 to 60%. The efficiency will be there for this type of the proton exchange membranes here. And notice the second one, if you consider the alkaline fuel cell type here, AFC that is. Here we are going to use the potassium hydroxide. Hydrogen gas is used as the fuel here, and oxygen it is acting as an oxidant in case of this. And the temperature also it is going to be less than 80 degrees. And the efficiency will be almost a 50 to 70%. The efficiency will be there if you are using the alkaline fuel cells here. The third one is nothing but the direct methanol. Okay, direct methanol fuel cell. Here in case of this, we are going to use solid polymer membrane here. And then the anode is nothing but the methanol solution. Methanol solution, that too in the water. Aqueous methanol we are going to use in case of this, right? The water, the oxygen used is nothing but the atmospheric oxygen. And the temperature maintained here is almost 75 degrees of temperature, and the efficiency will be 35 to 40 the percentage is going to be the efficiency. The next one is a phosphoric acid here. Phosphoric acid fuel cell. Here the phosphorus is going to act as an electrolyte. Anode gas is nothing but the hydrogen, cathodic is nothing but the oxygen, and the temperature is almost 210, more than 100 degrees of temperature we are maintaining in case of this, the phosphoric acid, the fuel cell type. Yeah. And the efficiency will be almost 35 to 50, right? The next one is a molten carbonate fuel cell type. In this case, we are going to consider alkali carbonate, like sodium carbonate, potassium carbonate, like that we can consider this, the electrolyte in case of this. And then the gas is maybe methane we can use, or if not hydrogen gas also we can use as an anodic gas here, as a fuel there. The gas which is used at the anode is nothing but the fuel here. The gas which is used at the cathode is nothing but the oxidant. Generally oxygen we are going to use. Because of that we are calling it as oxidant here, right? And then 650 degrees of temperature is maintained here, then the efficiency will be almost 40 to 55% the efficiency will be there for this type of the fuel cell, that is molten carbonate fuel cell. The next one is solid oxide. Ceramic oxides will we be using as the next electrolyte here, right? And the next, the anode is nothing but the fuel, it is nothing but hydrogen or the methane in case of this. Atmospheric oxygen we are going to use as an oxidant at the cathode, and the temperature maintained is almost 800 to 1000 degrees of temperature, and the 45 to 60% of the efficiency will be there for the solid oxide type of the fuel cells, right? This is proton exchange membrane. Means the protons from anode, it will be moving through the electrolyte towards the cathode to undergo the reduction process to produce the byproduct, that is water, along with the water, the electrical energy, that which the main product which is forming here, right? So here we are going to use the different types of the electrodes we are going to use, that is the carbon electrodes we are going to use here, okay? And then we are using a polymer membrane here, nothing but here the complete anode will be coated with the metallic substances here, okay? And also the type of the exchange, in the sense that whatever the electrolyte that we are considering there, just it should be have that capability of passage of these protons through them. So generally, in case of the fuel cell, the role of the electrolyte is it is very less when compared to the other batteries. In case of the lead acid battery, if you consider the sulfuric acid which is used there in the lead acid storage device, then sulfuric acid, based on the sulfuric acid itself, we are getting the lead sulfate, and then water we are getting as the main products, and then byproducts also, that is electron along with the electrical energy. Then the sulfuric acid is playing an important role. In case of the nickel cadmium battery, the potassium hydroxide is playing as an important role there. Till that particular the density of that particular sulfuric acid, when it reaches to 1.2 in case of the batteries, right? It is that particular reaction, it is that is a discharging process will be taking place. So there the sulfuric acid, the electrolytes, their role is very, very important. But here the fuel and then oxidant. The purpose of this, the electrolyte, is to just to produce the OH minus ions, or to allow the protons to move to the other electrode, that is the cathode there, right? This is the proton exchange membrane fuel cell, right? These are the different compartments, which is going to contain the backing layers here, which where the oxygen will be sent from the right side here. Okay, we can see that in blue color, the oxidant. Then hydrogen gas is sent from the left side here. Okay, and then unused fuel like a hydrogen, if it is left over, means it will be collected from downwards here. Okay, and anodic electrode is going to present a, right, which is blue in color. The cathode is also, it is blue in color, and then polymer electrolyte membrane. Okay, it is present between the two electrodes here, right, to allow the protons to pass through this. Okay, and this is the phosphoric acid. So here we are going to use the phosphoric acid as an electrolyte. Almost at 450 degrees of the Fahrenheit, we are maintaining this, and efficiency also, it is almost a 40% efficiency it is there. And one of the main important the advantage of this phosphoric acid is we can consider impure hydrogen also as a fuel here. Generally, in other cases, the pure hydrogen itself we have to consider in order to produce the electrical energy. But in case of the phosphoric acid fuel cell, When we are using the phosphoric acid as an electrolyte here, the impure hydrogen also can be considered as a fuel here, and then oxygen as an oxidant here, right? That is main difference between the other fuel cells and then the phosphoric acid fuel cells. This is solid oxide. So here we are going to use a non-porous ceramic compound as an electrolyte. In the middle of this, you can see this between these two electrodes here, the ceramic, the compound or the non-porous ceramic oxide, it is going to present it, and it is going to operate at almost 800 degrees of the temperature, and the energy efficiency is almost a 60% energy efficiency will be there in case of this, right? And is also widely used in industries, okay, and many. Even many research centers also this type of the solid oxide fuel cells are widely used here. Alkaline. In case of the alkaline, generally it is used by the military or the space programs like spacecraft, military vehicles, right? The alkaline is nothing but the potassium hydroxide, sodium hydroxide, potassium hydroxide, such type of electrolytes we are going to use, right? Even these alkaline fuel cells are used in the Apollo spacecraft also to provide the electricity. And also the water, whatever the byproduct which we are getting there, that is H2, it is going to act as the pure drinking water as it is used by the astronauts in the spacecraft, right? The water, it is used as a pure drinking water, okay? We are not wasting that water also in case of the fuel cells, right? And the uses of almost a potassium hydroxide, aqueous potassium hydroxide we are going to use, and it is maintain that the temperature maintained is almost a 75 to 160 degrees of temperature. It is maintained in this case. In laboratories, okay, hospitals, right, power stations, or the engines, okay, jet engines, okay, and spacecraft, military vehicles, right, any number, all not here. Even as an industrially, for laboratory, for diagnostic centers also, we are using this type of the different types of the alkaline batteries. This was an example for the alkaline fuel cell here. This is the diagram for this hydrogen oxygen fuel cell. But the catalyst, the electrolyte, it is going to vary the phosphoric acid, or if not the semi-oxide, okay, or if not, if you can consider this the solid polymer membrane, like the different types of the catalyst. These electrolytes will be varying, but the electrodes are the porous electrodes itself. Hydrogen or methanol or propanol, we can consider it as a fuel. But the oxygen, it is going to act as an oxidant in this case. Regenerative fuel cells. Generally, currently it was researched by this and NASA, even the NASA also, they're supporting and they're using this fuel cells there. And they're considering this hydrogen as a waste fuel for the rockets also, right? And the main drawback also, it is nothing but the carrying or the cost of this hydrogen gas, and not only that, for transportation purpose and for maintenance also, it is somewhat few drawbacks are there with respect to this hydrogen gas. Even though it is not causing any pollution, it is not emitting the toxic gases into the atmosphere. And not only that, even this, we can use the solar energy to separate the hydrogen from water. We are getting water means, or we are getting this hydrogen means by the decomposition of this, by the electrolysis of the water only, we are going to get the hydrogen and oxygen gas. Okay, so we can separate this, we can dissociate the water in order to get the hydrogen and oxygen by making the solar energy also. Okay, and then such type of hydrogen, the pure form, we are going to consider in the fuel cell, and we are going to produce the heat energy, at the same time light energy also. Hydrogen, the researchers generally, they are using the wide technology they are using and to produce this hydrogen. Even from bacteria, from algae, they are producing this hydrogen gas. They are finding in any number, in many ways, they are trying to produce the hydrogen from various sources also. So that as this hydrogen, it is eco-friendly, economically, it is many advantages are there for this hydrogen. So the researchers or the chemists and then scientists also, they are in search of the different types of the raw materials from which we can synthesize, from which we can separate this hydrogen gas. So these are certain methods like thermal process, electrolyte process, photolytic process. By using these methods, we can produce the hydrogen also, right? And the fuel cell technology can be used for transportation purpose, power station, right? So stationary power stations, telecommunications, micro powers in NASA also they are using, right? And not only that, even in foreign countries, right now they are using these hydrogen oxygen fuel cells itself. By using them, they are running the vehicles also, the boats, or if not the trucks, vehicles, cars, like that. In many ways, they are using the alternate energy resources. They are using the eco-friendly the fuels there in the foreign countries, right? Still now, but we are using these the fossil fuels, okay, and in some cases LPG and then also CNG also they are using for running certain vehicles, right? And benefits of the fuel cell technology, if you consider physical security, reliability will be there, efficiency is almost 70 up to 75%, 80% efficiency will be there by using these fuel cells. And it is environmentally the benefits also there, nothing but it is not going to cause any pollution. If you consider fossil fuels, if you consider petrol, diesel, like that, the carbon monoxide, different types of the toxic gases are released into the atmosphere, which results in the global warming. It is completely polluting the environment there. So instead of that, if you're using this fuel cell technology, right, it is eco-friendly and it is not going to cause any pollution in the environment also. And the battery replacement and also alternative for this what are the secondary batteries or the primary battery that we are using. Even a number of the military applications are there by making use of this fuel cell technology. And then production, steam reforming of the petroleum, space program, right? Storage, okay, cryogenic liquid here. Like this, the hydrogen right now we are using for different purpose. In space program as a fuel, we are using this in the rockets also, right? Production, biomass and electrolysis by using that method. And the fuel for the fuel cell for these, what are the fuel like the hydrogen or the methanol, we can use them. And innovative tank designs also, they are designing, they are going for they're using the, widely they're using the technology to still, how can we better, in a better way, how can we produce this hydrogen, how can we make use of the hydrogen for different activities or different purpose also, like that the chemists and the research persons, they are thinking and they are developing this also. So right now, even many people they shifted to these alternate energy resources like the solar energy or the tidal energy or wind energy, right? Instead of using the fossil fuels, right? And here the hydrogen production for future means alkyl production, okay, solar power based, right? Just for the electrolysis of the water, okay, we are using this the solar energy also and photochemical reactions also. By all these methods, we can produce the hydrogen gas efficiently also. Right, this, thank you for listening to my concept, okay. And this hydrogen oxygen fuel cell, it is the very important fuel cell, right, after batteries, right. It is going to play an important role in the future generations also, okay. Thank you very much.